Identify graph of polynomial functions. I'm Anil Kumar and I'll sketch some graphs for you. And you need to figure out which one of these are polynomials and which are not polynomials, right? And try to provide an explanation why they are polynomial or they are not polynomials. So that is the whole exercise. We'll kind of go slow so that we understand each and every graph very clearly. Okay, so first one which I am drawing is kind of like this. Is this a polynomial or not? Well, a very smooth curve moving from minus infinity to plus infinity with continuous domain is definitely a polynomial. So this one, no doubt, is a polynomial. So normally you're looking for such a graph, right? Or we could do something like this, right? So we could do like this. Now, is that a polynomial or not? Well, this is also a very smooth curve. Domain all real numbers. Range is restricted, but that means it's an even degree, and that one is an odd degree, correct? Now, here the leading coefficient is positive since the right side is up. Here the leading coefficient is negative as the right side is down. These two are definitely polynomials, correct? So let me sketch some more, and obviously I'm looking for those which are not polynomials. Here's a function whose domain is continuous, all real numbers. It is always increasing, right? Is it a polynomial or not? Explain why. Now we have a function like this and like this, right? So it goes on and on like this. Now, is this kind of a graph a polynomial or not? Or we could also have a function like this. For example, let me sketch kind of like this. So I'm trying to sketch so that it becomes very clear to you whether it is a polynomial or not. But that could be tricky. Think about it, right? Or at times we may have a function which has vertical asymptotes. Okay, so here is a function with vertical asymptotes now and a horizontal asymptote. Okay, so is this a polynomial or not? And what do you think is the reason for this graph, right? Now how about this function? So we have a function like this and we have a function like this and this. Now whether this is polynomial or not. Explain your thinking. Or we could have a combination of functions which is kind of polynomial here, and then we have a break here, and then it goes on. Now, so these are the functions, and you need to figure out which one of these are polynomials and which are not. Well, I think I've made the result very obvious. We know only two polynomials are here in this figure, and all these are not polynomials. What are the reasons? Well, reason here is that the function here is always increasing. Well, that really should not be the right reason. I can actually draw a polynomial which is always increasing. For example, if I draw a polynomial like this, right, it is always increasing. Do you see that? The reason here is horizontal asymptote. Polynomials do not have horizontal or vertical asymptote, right? If you are approaching negative infinity or positive infinity for a polynomial, they will also approach negative or positive infinity. They will not approach a particular value. So no horizontal asymptote. That is the reason. In this case, why this is not a polynomial? It's a very smooth curve, but it's not a polynomial since the range is limited from both the sides. You can have a polynomial with range limited from one side. Do you see that? Even degree polynomial. But this one, range is restricted between two values. Well, that is not a characteristic of polynomial. Here, it is a continuous function, smooth curve, but again, we are saying it is not a polynomial. What is the reason for this? The reason is at this point, if I try to find a tangent, it is like a vertical line. Do you see the undefined slope? On a polynomial, you cannot have a point with undefined slope. That is kind of important to understand. So this is very critical. So in a polynomial, what we realized here is no horizontal asymptote, right? So no horizontal asymptote. That is one thing we discover. Now restriction on range. Restriction on range, so I'll say Ry, both sides. That is not a polynomial. You can have one side, both sides. That is kind of critical, right? Here, what do we have? Here we have a vertical tangent, right? We have a vertical tangent, and therefore it is not a polynomial. And here we have vertical asymptotes, right? So we have vertical asymptotes and discontinuity. Therefore, this is not a polynomial. And here, these are sharp corners, right? Here we have sharp corners. And therefore, this is not a polynomial. And here we have a jump discontinuity, right? And therefore, it is not a polynomial. I hope with these examples now, given any graph, should be very clear to you whether it is a polynomial or not, right? I hope that helps. Thank you and all the best.